Ever stared at a can of milk powder and thought, how do they get all that liquidy moo juice into this fine, dusty stuff? Milk, that wholesome liquid, seems a world away from a shelf-stable powder. Yet, for generations, we've been transforming it to last longer and travel farther. This isn't kitchen alchemy but a carefully orchestrated industrial ballet. It's a journey from udder to powder, more fascinating than you might think. Turning it into powder extends its life from days to months, even years. It's a delicate balance, ensuring the powder you rehydrate still packs a nutritional punch. Milk powder means you can have milk on hand without worrying about expiration dates. From infant formula to chocolate bars, milk powder is an unsung hero of the modern food supply chain. Alright, let's get down to brass tacks. What exactly milk powder? Simply put, it's what you get when you take fresh milk and remove almost all the water. Think of it as milk concentrate, taken to the extreme. The goal is to reduce the moisture content to a very low level, typically around 3 to 5%. By drastically reducing the water, we make it incredibly difficult for bacteria, yeasts, and molds to grow and multiply. This is the fundamental principle behind its remarkable shelf stability. Now, why do we bother going through all this trouble? The benefits are numerous and significant. First and foremost, as we've touched upon, is shelf life. Fresh milk might last you a week, maybe 2 if you're lucky and your fridge is Arctic. Milk powder, when stored correctly in an airtight container in a cool, dry place, can last for months, sometimes even years. This extended lifespan is a game changer, especially in regions where fresh milk isn't readily available or refrigeration is a luxury. Beyond longevity, there's the matter of volume and weight. By removing the water, we significantly reduce both the weight and volume of the milk. This makes transportation far more efficient and cost-effective. It's a logistical superhero in disguise. The journey of milk powder begins long before any powder is actually made. It starts, as you'd expect, on the dairy farm. Healthy, well-nourished cows are the foundation of good quality milk, and therefore good quality milk powder. Farmers work diligently to ensure their herds are in top condition, because the composition of the raw milk, its fat content, protein levels, and overall hygiene, directly impacts the final product. Once the cows are milked, usually twice a day using modern hygienic milking systems, the clock starts ticking. Raw milk is a highly perishable product, a perfect medium for bacterial growth if not handled with extreme care and speed. Immediately after milking, the raw milk is cooled. This is a critical first step in quality control. The milk is typically chilled to around 4 degrees Celsius. That's about 39 degrees Fahrenheit for US stateside folks. Lowering the temperature significantly slows down the growth of any bacteria that might be present, buying precious time. Many farms have on-site refrigerated bulk tanks, where the milk from multiple milkings is stored temporarily. These tanks are often equipped with agitators to keep the milk mixed and maintain a uniform temperature. Next up is transportation. Specialized insulated stainless steel tanker trucks arrive at the farms to collect the chilled milk. This entire collection and transportation process is a carefully choreographed operation, focused on speed, hygiene, and temperature control, all to preserve the quality of the raw milk that will soon become powder. Once the raw milk arrives at the processing plant and passes initial quality checks, it undergoes standardization. This process adjusts the fat level to a specific percentage. A centrifugal separator spins the milk, separating skim milk from cream. Processors control the fat content by removing or adding cream. Next is pasteurization, named after Louis Pasteur. High-temperature short-time (HTST) pasteurization heats milk to 72 degrees Celsius for 15 seconds. This step ensures milk safety and quality for powder production. Section 5. Concentration is key. The evaporation station. With the milk standardized and pasteurized, it's now safe and has the right fat content. But it's still mostly water, about 87% water to be precise. Trying to dry this directly into powder would be incredibly energy-intensive and inefficient. So the next logical step is to remove a significant portion of this water before the final drying stage. This is where evaporation comes into play. The goal here is to concentrate the milk solids, typically increasing them from around 13% in liquid milk to about 45 to 55% in the concentrated milk. This concentration is usually achieved using a piece of equipment called an evaporator, often a multi-effect falling film evaporator. Sounds complicated, but the principle is straightforward. Reduce the pressure to lower the boiling point of water. Milk flows as a thin film down the inside of heated tubes under a partial vacuum. Because water boils at a lower temperature under reduced pressure, it can be removed efficiently without overheating and damaging the milk's delicate proteins and vitamins. Using multiple effects or stages where the vapor from one stage is used to heat the next, makes the process much more energy efficient. The evaporation process is carefully controlled. Parameters like temperature, vacuum level, and flow rate are continuously monitored and adjusted to ensure optimal water removal and minimal heat damage to the milk solids. The evaporator acts as the heavy lifter for water removal, preparing the milk perfectly for its transformation into powder. Section 6. Making it rain powder, the magic of spray drying. Now we arrive at the heart of milk powder production, the step where the concentrated milk actually becomes a powder. Spray drying. This is where the real transformation happens, turning a liquid into fine, dry particles in a matter of seconds. The concentrated milk, now with about 45 to 55% solids, is fed into a spray dryer. This is typically a very large, tall, cylindrical chamber, often several stories high. At the top of this chamber, or sometimes from the bottom in certain designs, the concentrated milk is atomized. This means it's broken up into incredibly tiny droplets, creating a fine mist. This atomization is usually done using either high-pressure nozzles or a rapidly spinning atomizer wheel. The purpose of creating these minuscule droplets is to massively increase the surface area of the milk. This vast surface area is crucial because simultaneously a stream of hot air, typically heated to between 150 degrees Celsius and 220 degrees Celsius, that's roughly 300 degrees Fahrenheit to 430 degrees Fahrenheit, is blown into the drying chamber. As the fine mist of milk droplets comes into contact with this hot air, the remaining water evaporates almost instantaneously. The key here is instantaneously. The contact time is so short that even though the air is hot, the milk particles themselves don't overheat. As the water flashes off, what's left behind are tiny dry particles of milk solids. This is our milk powder. It's a sophisticated piece of engineering, turning liquid gold into powdered treasure. Section 7. Cooling, sifting and smoothing, the finishing finesse. Once the milk powder emerges from the spray dryer, it's not quite ready for prime time. The next steps involve cooling the powder and then sieving it to ensure a consistent, high-quality product. The powder needs to be cooled down to around 20 to 30 degrees Celsius before packaging. Cooling prevents clumping and stabilizes the powder, especially the milk fat. This is often done using a fluid bed cooler. After cooling, the powder passes through sieves to remove oversized particles and lumps. These steps ensure the powder meets high standards for consumers and food manufacturers. Section 8. Sealed for freshness. Packaging and storing the goods. We've dried it, cooled it, and sifted it. Our milk is now officially powder, looking fine and ready. But the journey isn't over yet. How we package and store this precious powder is just as crucial as how we made it. Milk powder, despite its dry nature, is still sensitive. It can absorb moisture from the air, which can lead to caking, spoilage, and a shortened shelf life. It's also susceptible to oxidation, especially whole milk powder with its higher fat content, which can cause rancidity and off flavors. Therefore, the packaging needs to act as a robust barrier against moisture, oxygen, and even light, which can also degrade certain vitamins. The choice of packaging material and design depends on the type of milk powder, the intended market, consumer or industrial, and the desired shelf life. For retail consumers, you'll often see milk powder in multi-layer pouches, metal cans, or composite cans, cardboard tubes with metal ends. These materials are chosen for their excellent barrier properties. For example, pouches might use layers of plastic and aluminum foil. Cans provide a hermetic seal. Often before sealing, the air inside the package is replaced with an inert gas like nitrogen or a mix of nitrogen and carbon dioxide. Section 9. A powder for every purpose and the final word. Not all milk powders are created equal, nor are they all used for the same thing. The most common types are skim milk powder, SMP, and whole milk powder, WMP. SMP is made from skimmed milk with low fat and high protein content. Ideal for low-fat yogurts, baked goods, or as a protein booster. WMP retains its original fat content, giving it a richer flavor and creamier texture. Used in infant formula, chocolate, ice cream, and bakery products. Buttermilk powder, a byproduct of butter making, is popular in baking mixes. Each type has its own unique profile and purpose.